sometimes it takes a couple more rounds to get a polynomial fully factored. So we'll factor for a while, and then we'll discover that the factors of the factors of the factors can still be factored. We just keep going until we're down to factors that are prime. Our first move, always, is to factor out the GCF. So here is a polynomial with 4 terms, 5x to the 6th plus 15x to the 5th minus 5x squared minus 15x. And we see that each term has a factor of x to some power. The lowest power is x to the 1. So our GCF is going to have an x in it. And we also notice that each of the coefficients is a multiple of 5. So our GCF is going to be 5x. We'll factor that out. 5x times 5x to the 6th divided by 5x is going to be x to the 5th. 15x to the 5th divided by 5x is going to be 3x to the 4th. Negative 5x squared divided by 5x is going to be negative x. Negative 15x divided by 5x is going to be negative 3. Okay, so we've factored out our greatest common factor. Our remaining polynomial factor has 1, 2, 3, 4 terms. So the next thing we're going to try is grouping. Putting in my factors in descending order, I'll have x to the 5th plus 3x to the 4th minus x minus 3. Greatest common factor in my first row is an x to the 4th. X to the 4th times what is x to the 5th? Well, that's just an x. X to the 4th times what is 3x to the 4th? That's a plus 3. X times what is negative x? That's a negative 1. Negative 1 times 3 is negative 3. Grouping does work sometimes. Grouping worked here. My x to the 5th plus 3x to the 4th minus x minus 3. That factored as x plus 3 times x to the 4th minus 1. Okay, so now I've factored my original polynomial, taken out the GCF, factored the remaining polynomial factor, and now I want to look at each of those factors and see if I can factor further. And we start out pretty easy. X plus 3, the first one of these binomials, well, that's linear, and so it's prime. That's pretty easy. What about my second binomial factor? Well, x to the 4th minus 1, I think that's a difference of squares, right? I have x squared squared minus 1 squared. So I can factor that as x squared minus 1 times x squared plus 1. Okay, so I have factored my x to the 4th minus 1. But the factors I got are not linear. They're not obviously prime. Let's see if I can continue. The first one of those factors, x squared minus 1, well, that's x squared minus 1 squared. That's a difference of squares again. So we'll have x minus 1 times x plus 1. Okay, these guys are linear now. They're prime. And that guy's factored. The x squared plus 1, well, I think that is a sum of squares. So that's prime. Okay, so I think that we've now dealt with all of our factors. Our x plus 3 we said was prime. Our x to the fourth minus 1 we factored further. Our x squared minus 1 we factored further. But our x squared plus 1 we said was prime. Those two linear factors we said were prime. I think we've got everything now. So let's make sure we get everything. We have our greatest common factor of 5x. We've got that. And then we have our x plus 3. That didn't go anywhere. We've got that. That was this. And then our x squared minus 1, that factored. So we're not going to put that in. Our x squared minus 1, that factored. We're going to put in its factors. So we'll put in our x minus 1 and our x plus 1. And then this x squared plus 1, we decided that was prime. So x squared plus 1. And looking around, I see that I've dealt with everything. Every factor that I got along the way, I've either included it in my factored form or it factored further and I included its factors. So this is the factorization of my original polynomial. This is 5x to the 6th plus 15x to the 5th minus 5x squared minus 15x. And if I want to make sure I got everything, I can go ahead and multiply that out and confirm that I get my original polynomial back.